Our next speaker is Dr. Francesco Astorri from Italian Institute for Environmental Protection and Research. The title of his presentation is Italian Legislation and First Experimental Project of CO2 Geological Storage in a Depleted Gas Field. Dr. Astorri, thank you.
Thank you, Chair. Thanks to all delegates here in presence and everyone attending the meeting remote mode as well. And thanks to the Secretariat for giving us the opportunity during this Science Day to describe and share information and experience on the first application of Italian regulation system on a project dealing with carbon capture and storage on sub-seabed geological formation. I introduce myself. I have been working in ISPRA, the Italian Institute for Environmental Protection and Research, for 25 years. I'm an environmental inspector. I have an extensive expertise in environmental inspection and in safety management system inspection on those plants that can cause a major accident and are subjected to Seveso EU directive regulation. Additionally, I have actually a coordinating role within the CCS National Technical Secretariat, especially in evaluating these Italy first experimental projects of CO2 capture and storage that I'm going to present this afternoon. What will we discuss this afternoon? So, we will provide you with an overview of the current legislation in Italy regarding the geological storage of carbon dioxide. Additionally, we will offer a brief description of the approach used to evaluate Italy's first experimental CO2 subseabed geological storage project. For this second item, the focus will be on environmental protection measures and the prevention measure against accidental releases and the monitoring strategies to be implemented as well. In Italy, the Law Decree 162 of 2011, the so-called Mother Decree, transposes almost completely the CCS European Directive number 31 of 2009 and establish the first framework of measures to regulate the permanent geological storage of carbon dioxide in geological formation. It regulates administrative and technical procedures for identifying suitable storage areas, issuing exploration licensing and storage permits, define monitoring rules, inspection, interventions in case of accidental release or irregularities detected, obligation for the operator for closure and for post-closure of the site, transfer of responsibility, and guarantees financial contribution. Further law decree issued in 2020 and 2021 introduced some important amendments to the Mother Decree in order to simplify procedures for experimental storage programs referring to depleted gas or oil field reservoirs. Two of them was respectively that an experimental project were excluded from submission of a monitoring plan, and the programs involving an injection volume of carbon dioxide less than 100,000 tons of CO2 were excluded from the submission of an environmental impact assessment as well. The last law decree issued on December 2023, so-called Energy Decree, states that depleted offshore reservoirs are suitable storage areas for every CCS programs. In the same decree, procedural process on experimental storage programs were also well defined. the distinction between experimental program and ordinary program falls away with regards to the submission of the monitoring plan. In practice, that is that the monitoring plan now must always be submitted by the operator, also in case of experimental programs. Financial guarantees, in example, the criteria for establishing the fees the operator must put up to cover any damage to environment were better defined, and the fees for administrative and technical evaluation of the project were well defined. The decree tried also to determine two important aspects by means the activation of two research lines. The first one aimed to define the Italy CCS supply chain by passing through the estimation of cost involved in CCS project, identification of cluster of facilities considered as source of CO2, and cluster of storage sites as well, defined in terms of storage potential capabilities. And third, identification of preferential corridors for the development of transportation facilities, principally pipelines. The second one item, line of research, regards in fact the implementation of technical rules for pipeline transports. Now we will explore how the process of issuing storage permits operates in Italy. It's not a simple process. We will begin by examining what the Italian regulation define regarding this process and which authorities are involved. In Italy, the Ministry of Environment and Energy Security acts as the unique competent authority responsible for issuing storage permits. These administrative authorities issue permits based on the judgment of a technical national committee for the management of a European Directive number 87 of 2003 and for supporting Kyoto Protocol project activities. This committee is tasked with providing a technical evaluation of every CCS project. To assist in the evaluation process, the committee is supported by a technical secretariat. Additionally, the technical secretariat can enlist the expertise of various national technical bodies, such as my institute, ISPRA, INGV, the Volcano and the Seismic Institute in Italy, National Institute, the Alt Institute, and other technical bodies. How do we control permit requirements after issuing the process? Through the coordinated efforts of 3 designated technical bodies and the implementation of various inspection procedures, compliance with storage permit requirements is effectively monitored and ensured, contributing to environmental protection and safety. These designated technical bodies are UNMIG, the National Public Offices for Mining Activities, that controls the implementation of mining policy regulation and provides technical support to the committee within the technical secretariat. ISPRA, my institute, that supervises environmental monitoring action carried out by the operator on the storage complex, also utilizes regional agencies for environmental protection. ISPRA also offers technical support to the committee within the technical secretariat and collaborates with the regional environmental protection agency. National Fire Brigade body that verifies the adoption of technical and management measures aimed at risk control and management of emergency situations. Inspection may be ordinary or scheduled at intervals of 1, 3, or 5 years. Extraordinary inspection occur in case of significant irregularities or accidental CO2 releases, if no compliance with permit condition is identified, and following reports of hazard to the environment or public health and safety. What the operator must submit to obtain a storage permit and what must be proven. In accordance with the Modern Decree, the 162, 1211, the operator of the plant must include the following details in the project application submitted to the competent authority. A characterization of the storage site, that is, a comprehensive evaluation from various perspectives, including geological, geotechnical, structural, seismic, and environmental aspects. An assessment of storage security, that is, documentary evidences such as studies and research, demonstrating the integrity of the cap rock and the monitoring mission on potential migration pathways for injected CO2, including active fault and fracture systems, as well as the injection well itself or other abandoned wells. This might be done by means also the application of simulated models of diffusion and behavior of CO2 in the reservoir rock. A monitoring plan, now mandatory for experimental programs below 100,000 tons. That is the implementation of an environmental monitoring system for identified parameters to monitor deviation from simulation results and intercept any adverse effect from CO2 release. A plan for corrective actions include measures to prevent significant release and technical plant irregularities, procedures to minimize CO2 leakage risk, and measures to mitigate harmful effects resulting from release. A plan for the post-closure phase that describes control measures to be implemented on closed wells after injection is completed, and demonstration of the applicant's technical and economic capacity. So, the project. The first experimental CO2 geological storage project in Italy was authorized on January 2023. The duration of the permitting process was less than 1 year. The project consisted on capture of the CO2 from emission in an offshore plant, transfer by means of existing sealands to offshore platforms in the northern Adriatic Sea, injection and permanent storage in a depleted level of a natural gas field located at a depth over than 2,000 meters for a total volume of injected CO2 of 50,000 tons with a maximum duration of 2 years, about 25 tons per year. The thickness of the water column in the affected area range from 0 to 18 meters. That it is important to note that injection will be carried out by reconditioning an old well to a depth of 315 meters and then continuing in sidetrack mode until the reservoir geological formation is intercepted at a depth of more than 2,900 meters. As this is the first CO2 storage project, a precautionary approach was adopted under which further aspects of environmental protection, not only concerning the security of the storage complex, were also analyzed. First of all, the operator was called upon the reconstruction of the static geological model, the generation of the three-dimensional dynamic model that is the simulation of CO2 injection condition, the implementation of a geophysical monitoring of soil deformation network, the implementation of microseismic monitoring network, the evaluation of tsunami risk, the implementation energy management procedures, the computation of emission of pollutants in the offshore and onshore environments generated during construction of plant. Also, accidental leakage of CO2 were also considered through model simulation of the dispersion and transport of CO2 and analysis of the potential effect on the marine environment. Two different CO2 release worst scenarios were investigated in different climate conditions. The first one was a pipe break caused by a ship anchor on the seabed. The second one, a pipe leak caused by the rupture of the pipe in a flanged fitting or by corrosion. Then an analysis of the consequence on aquatic organisms due to water acidification and thermal shock has been carried out, considering the following target species: phytoplankton, benthos, zooplankton, fishes, marine reptiles, and marine mammals. Although at the time of the project application and authorization, regulation did not request a mandatory monitoring plan because it was an experimental project, specific monitoring activities were planned, both offshore and onshore. Potential CO2 leakage to the surface, even if not likely, will be detected through well monitoring and environmental monitoring. While monitoring must verify that the performance of the injection process in terms of injection rate, physical and chemical condition of the injection stream, expected pressure and plume migration occur according to the model prediction, and at the same time CO2 confinement is guaranteed. These monitoring actions are planned both before and during the injection to measure the effect at the reservoir level, in the cover, or at the surface. Environmental monitoring aims to detect any CO2 leakage through a series of multidisciplinary surveys. They include geophysical surveys of the seabed and the water column, acoustic surveys, leak detection, physical and chemical and biochemical surveys of water and sediments. Monitoring activities will also consider the impact to marine fauna potential attributable to changing the chemistry of marine water, mainly originating from the reduction of pH values, as we saw on one of this in the previous slides. So, this slide shows just some outcomes from the evaluation process and the most significant requirements reported in the storage permit. Some of these responds to the question that our colleague of Greenpeace raised last Monday. The injection facility must be equipped with automatic injection shut-off systems in case of deviation of fluid composition from the authorized limits detected by continuous CO2 and CO measurements. As a maximum pressure limit at the bottom of well, the operator shall not exceed 24 megapascal, about 240 bar approximately. The operator shall place at the bottom of well dedicated instrumentation for continuous detection of pressure and temperature of the injection fluid. The operator shall implement a microseismic network considering realistic estimates of background seismic noise. Preventive monitoring at the beginning of the activities will also have to be carried out in order to be able to verify unperturbed condition, ante-operam requirement. With regard to the ground deformation monitoring, the operator shall install new GPS station part offshore on each existing platform currently lacking such instrumentation in order to better track deformation at the CO2 storage reservoir. If noise level potentially impacting the species Tursiops truncatus and Caretta caretta are exceeded during this operation, Appropriate meeting and measurement will have to be applied, such as the use of bubble curtains or other acoustic mitigation measures, until temporary shifting of operation to protect the most sensitive periods of the species involved. So, the conclusion, the Law Decree 162 of 1211 outlined the issuance of several ministerial decrees to regulate specific aspects of the activities, which, however, remained unimplemented in subsequent years. Despite the efforts made by the last decree, 181 of 2023, to address some of these shortcomings, there are still provisions awaiting implementation. Presently, in the short term, as we described before in the slide number 1, initiatives such as the CCS supply chain study and the development of CO2 transport technical regulation in pipeline are being developed. Thank you for your attention.
Thank you, Francesco, for your interesting presentation on the environmental and technical assessments conducted to evaluate potential impacts and risks of the project. I will now open the floor for questions. Greenpeace, you have the floor.
Thank you, Chair, and thank you for yet another interesting presentation. And it's good to see the information being shared at a very early stage of the development of the CCS infrastructure within Italy. We had 3 questions. The first related to the justification and the implications of the 100,000 ton cutoff for requiring an environmental impact assessment. On the face of it, 100,000 tons already sounds like a lot. So we wonder, and would have, of course, is bigger than the current test project that's being done. So it's a large quantity. So could you say something about why that cutoff was made at 100,000 tons, and looking ahead, whether that could be exploited to apply for lots of small permits in order to keep below that threshold for an environmental impact assessment? The second question, you mentioned about measures to contain the harmful effects resulting from releases. And I wondered if you could describe what they could be, what in practice could be done if there is a release. And the third related to the environmental monitoring. So just to understand what the expected periodicity would be, how frequently the monitoring would be done, and how far post-closure that would be expected to continue. Thank you.
Thank you, Greenpeace, for the question. The first was the reason of the 100,000 limit. So the limit is considered considered in relation to the storage capacity of the reservoirs. For instance, these 2 levels in which we are carrying out this experimental project have a capability of range from 5 million to 7 million standard cubic meter. So 100,000 tons are a very small quantity of CO2 that we can inject. Another consideration is that this reservoir already contained gas, and so they were well monitored yet. So the request was just the implementation of integrate the microseismic network and the microseismic and the ZPS for detect any other soil deformation. This is considered a limit in which, for experience, is not necessary to make an environmental impact assessment because the quantities are very small with respect to other authorization that implies more quantities to injection in the future and more quantities that we can take from oil or gas material. The second question was I don't remember if you can repeat, please, regarded the...
Yes, thank you. It was, you had a mention on your slides of measures to contain harmful effects resulting from releases.
Yes, yeah, okay, I remember. Yeah. But the main measure to of oil industry, on the oil extraction industry, and so they are principally valves like that prevent from blow up because the danger, the major danger is eventually problem and troubles that could derive from the injection well, because in the case of depleted reservoir have been never registered problems of release from fault and fracture systems, for instance. And the only problem that we can register is the probability of occurring a blown up accident from the injection well. So many monitoring system we can implement, and so they are from experience of oil gas extraction industry. So we not consider a problem. And the third question was some example of monitoring measure, if I remember.
It was more the frequency with which the environmental monitoring would take place and how far beyond closure of the injection.
Okay.
Thank you.
There is the monitoring measure are are aimed to detect the zero condition, so before the injection of the CO2, during the injection of the gas, and after the post-closure. And we considered a frequency of 4 survey every year during all the period of the injection of the CO2.
Thank you, Greenpeace, and thank you, Francesco. MRS, do you have the floor?
Thank you. Just a quick question. Thank you for presenting the outcome and the results, but for engineers and scientists, it's always good to dive a bit more into the details. And is the full report publicly available anywhere? Can we have the full?
So a part of the judgment was issued by the ATS committee, and the authorization permit is you have to have is not on internet. You have to apply a formal request to the competent authority, that is the Ministry of Environment, and or directly to the Kyoto Protocol Committee, because in the permit are reported just the requirements that are 20 20 requirements, 20 provisions, but the entire document are 189 pages, so you have to apply a formal request. But the normal channel of requests you can, every citizen can do. Thank you.
Thank you.
Thank you. Seeing no further questions, I will hand over to Jan to introduce our next speaker.